this talk combines the dynamicity of risk management as well as how to check or assure the responsible AI properties of the AI-enabled solutions. Current risk management practice is more static. They are not focusing the dynamic parameters. So that's why the risks you quantify is not accurate risks that you need to take into consideration. So this talk is very interesting in terms of understanding what is the dynamic things that you need to take into consideration for the risk assessment. How can you make sure the AI-enabled solution give you the right decision and the responsible AI practice?
Welcome to talk.cybercni.fr.
So, welcome to the 36th edition of the Talk Cybersecurity Speaker Series, your monthly enlightenment towards cybersecurity. And I'm super happy for today's talk. So today we'll have Shareeful Islam from Anglia Ruskin University in the UK. And Shareef will be talking about cybersecurity risk management with responsible AI practice for enhancing and resilience of digital infrastructure. You already heard about what roughly this will be about in his introductory words. As always, the series lives with your interaction, and therefore you're cordially invited to join these. Not surprisingly, today's your analyst talk 36 edition of the talk. And please scan the QR code, join the channel, and there you will see questions, what is happening. You can upload and download questions, and as always, the format will be we have a presentation, first half roughly of our 90 minutes time slot, and then afterwards we'll have also room for discussions based on your questions, so that we can even dive deeper into the topic. So, let me briefly introduce Shareef. So Dr. Shareeful Islam is an associate professor in cybersecurity at the Faculty of Science and Engineering at the Anglia Ruskin University in the UK. He is currently a visiting professor at the LUT School of Engineering Sciences, Lappeenranta, Finland, and previously worked as a visiting professor at the National Institute of Informatics in Japan, and as a visiting researcher at the SBA Research in Austria. He has over 22 years of experience in teaching, administration, and research. He published more than 90 papers and secured a £140 million funding, mostly from the national and EU funding agency. He is experienced with the lead and managing projects. He has successfully supervised to timely completion 11 PhDs and Masters of Philosophy, and currently leading the Horizon project for cybersecurity, probably for ARU. He has published more than 90 papers in different top-ranked journals and conferences, and his research interests include cybersecurity risk management, responsible AI, AI-enabled cybersecurity, and regulatory compliance. And without further ado, Shareef, it's a great pleasure having you, and we're really looking forward to your presentation. So I hand over the floor to you. Stage is yours.
Okay, thank you, Mark, for inviting me for this exciting presentation. So I really look forward and attending this session. And should I start my presentation now? Okay. You can see my screen, right? Okay, so thank you once again. As already, I guess Mark says that this presentation is about the dynamic cybersecurity risk management with the understanding that how could you deal with the explainability and interpretability of the AI model. And because as you know that all the cybersecurity enabled solutions is now focusing on how to adopt the AI practice. So that means that we need to look that how could you ensure the explainability and interpretability of this AI model. So this talk gonna focus on how could you manage the risks from the dynamic context, as well as when you adapt the AI parameters, how could you ensure the explainability and interpretability of the model. So thank you, Mark, once again. So my name is Shareeful. I work in the Anglia Ruskin University, Faculty of Science and Engineering. Not sure all of you know our university, Anglia Ruskin University. So this is located in 3 campuses across the UK, but my campus is in Cambridge. So our Faculty of Science and Engineering building is located in Cambridge, where our department or school of Computing and Information Science, where I'm working. And I have also linked with my website. So if you have any further information you would like to know about ARU, please visit my site. All right, so this outline of this talk, I'm going to discuss about the what is the context now, cyber security risk management, because as you know that we are talking a lot about cyber threats, cyber risk. Now the question comes is how could you manage the risk, right? So to manage the risk, there is a number of methods that is exist. So my goal is to give you an overview of what is the context of current cyber security risk management. Then I would like to talk about that if you want to deal with the cyber security and where you want to incorporate that any AI enabled capabilities, then what is the current context and what are the challenges you face of adding the AI enabled capabilities in cyber security. Then I would like to give you an overview of the AI Act, which is recently introduced in EU, and I think this will come in place very soon. So I guess this is the right time now for all of us to focus on how you can achieve the compliance of AI Act. And in our case, how could we achieve this compliance by looking at cybersecurity based product? Then I'm going to give an overview about the dynamic risk management. That is our proposed work that we are doing currently with our team and some industry collaboration. Then finally, experiment and result. Okay, so what is the context currently in cybersecurity risk management? If you look at the current threat context, for example, the cyber attacks is now very, very sophisticated. Like I don't know, some of you know that in very recently in UK, we cannot do any blood test. Why? In the last few years, because uh, the whole testing system is affected by a cyber attack, and the system is down, and there are some they are not giving any service to do the regular blood test, and I'm also a victim of that. So I could not do my blood test in the last 4 weeks, which I was scheduled to supposed to do in 3 weeks back. So that reason I'm telling you is that this sophisticated nature of the attacks is increases. So if you are a victim of your organization is victim, then severity could be high, and it is almost certain that any business could be affected by any cyber attack at any time. You cannot guarantee that you are protected. Doesn't matter how much security you have put in place. Okay. So that's why the risk management come in place to understand the risk and put some right level of mitigations to address these risks. Now, this risk is very much context specific. Like the risks in a in a financial institution is not same the risks in a higher education institution, right? So that means that it is depending on the context, the nature and severity of the risk is change. And if you look at the modern architecture of the business, so we are calling it the modern digital infrastructure, it is very, very complex, right? So every day we are bringing new applications, we are updating the applications. So these are the subsystems which you are always connected with each other. So that's the current context of our digital environment. Now, in this context, what is the problem of cyber risk? One of the key problem is the cascading impact that I told through my example is that I could not do my blood test which was scheduled in I think 3 weeks before. So that means that if one system is affected, then that could propagate to the other systems. Like you see the attacks happen here, so this is propagating to the every part of the network because we are all system is now digitally connected. So that's why we call it cascading impact due to the cyber asset dependencies, which is very, very severe nowadays, right? For example, if you have a attacks that is propagating from one system to another system, that means severity would be very high, right? For any of the business context. So that's why this is one thing of the cyber risks. Then another thing is the evolving organizations. Like for example, there are new applications you are continuously adapting to run the business, and we are reconfiguring our existing asset, we are reconfiguring our asset dependencies, right? So these are the common business as usual practice now for any organizations. Then threat landscape is also evolving, that I said before. And when you bring a new device, and if the device you bring from any third party, then obviously if you don't know the security nature of this device, then obviously there should be new attack surface on your context. So this new attack surface means there are more potential that threat could be exploited. Okay, then we have a vulnerabilities, and any vulnerabilities can be exploited at any time. So from our research, we see that these are the parameters that is continuously evolving for any business. Now, these parameters certainly impact on your measuring or tackling the risk. Now, traditional risk management practice that we follow now, for example, we identify the risks, we analyze the risks, then we mitigate the risks, right? Now, in this traditional risk management practice, I think there is a very less or limited focus on these parameters that I discussed in my previous slide. Like, for example, parameters relating to how many vulnerabilities could be exploited in your context and how these vulnerabilities could be incorporated in the risk assessment. So if you don't consider these temporal parameters, then the issue is your risk identification could be inaccurate, right? Your risk estimation could be inaccurate. So that's one key challenge in the risk management practice now. Then another thing we see that, uh, as you know that I guess some of you know what is a vulnerability. So every day we have a number of vulnerabilities published, and these vulnerabilities are product based. For example, if you're using Microsoft Windows, there are list of vulnerabilities from the Windows. If you're using Cisco firewall, there are a number of vulnerabilities relating to the router firewall of Cisco, something like this. Okay, so when these vulnerabilities is published, then if you look at this diagram, so these are the all published vulnerabilities. Now currently we have more than 1 million vulnerabilities published across the world, right? But you don't need to control all of them. So you need to control at least those which are exploited. So if you look at this circle, like only this red part is the key for your business that need to be audited, because all the vulnerabilities published may not be exploited, right? So those of the vulnerability that could be exploited, so you need to take care of that. Okay, and out of this exploitation, some of them is related maybe your product of the business, some of them may not be related to your product. So that means that somehow a big list of vulnerability, you need to filter it and you need to prioritize it to look that which one is relevant for this business. I think this is one of the key motivation of our work. So we want to see that how could you prioritize those vulnerabilities that are that has very high probability of exploitation. So if you know that out of this 100, these 5 vulnerabilities are high probability of exploitation, then you can take them and adopt them for your risk assessment. And that is the risk that you need to take into consideration. You are not going to take into the risk based on your environment, right? So then it will be too much for you, and your risk management will not be effective for your context. So you have to look only those that is in the red button for you. All right. So I think that's one of the motivation of this work. And from, as I said, that there are a number of dynamic parameters, but we are currently working with the dynamicity of the vulnerability exploitation in our case. Okay, this is one context, as I said, and another context is the AI-enabled cybersecurity. Like that now any sector or any application domain is currently taking the advantage of the AI capability. So that means that currently AI is now widely adopting in any sector, right, or any application domain. So the main motivation is like we have a huge number of data generated. Like for example, in this case, we have a huge number of vulnerabilities generated. So you cannot do it manually or any other process that can analyze all of them. So we need some sort of process that can analyze the data for you. So that's why the AI come in place, right? For example, your log data, your vulnerabilities data is huge. Like every day is generating tens of log data, right? So you cannot deal with it in any other way. So that's why AI is come in place, and this will allow you to facilitate the model to undertake the proactive action for risks. It will improve your accuracy of threat detections, and it will sufficiently support you to reduce your false positive as well from there. And AI system is, as you know, that due to the nature of the system, it is continuously running. So that's why if you have a huge amount of phishing data, malware data, your security operating system, they are now AI based features is now very popular in all this application domain under the cyber security context. All right. Now, what is the challenge? Now we already know the benefits of using AI. I think across any application domain. But the challenge now, this is the time for us to look at this challenge of how we can really use the AI and how could you tackle mitigating these challenges. Otherwise, AI is cannot give you always benefited. There could be some negative side effect of that which we need to take into considerations. So from that point of view, I think if you look at the government policies or any sector specific policy, they all of us is now looking for trustworthy AI system. So trustworthy AI system is know that this malware, yes, okay. Okay. Sorry, apology for this. I think technical issue is out of our control. So I said that AI, we are talking a lot about the AI, but this is the time for us to focus on what are the challenges we are facing from the AI. Okay. So from that challenge point of view, the government, the regulated agency, all of us now focus on how we can develop a trustworthy AI system. Okay. Otherwise, you don't know that your AI system can say that this is the malware, then you don't know that why this malware need to be protected, right? So that's why we need to look at now how do you explain and interpret the model that is generating from the AI system? How do you increase the trust and accountability of using AI system? If you are unable to do that, that means that you are now lacking behind this trustworthy system. So I'm sure there are many challenges, but I think scope of our work is focusing on these two challenges. Okay, so if you look at this system, that how trustworthy is the AI system? Like for example, I give you some scenario from there, like Trump supporter target black voters, with some fake AI images. That is a negative side of the AI. Then you know that there are two high-profile executives of the OpenAI. They are resigned due to they are really concerned about the safety issues of the AI. Or AI can make scam email looks genuine from the UK cybersecurity agency. So you see, there are many examples like this. So now the question is come now to us really that we know that AI could be adapted in any applications to give you benefit, but how could you know this is a safe system? How could you know that AI is trustworthy for your system? So at the end of the day, how could you control the AI system? Okay. So from that point of view, I think EU AI Act is now introduced as in the market. So basically, EU is, I think, one two step forward than other continent in terms of legal enforcements of regulating the AI based system. So this UAI Act is their primary goal is to ensure that AI system is developed in use in the AI are very safe, ethical, transparent, and this give you all the fundamental rights of the system. Okay. Now, according to UAI Act, all the AI-based applications should be categorized among this triangle. Like if you look at this triangle, you can see that some of the systems could be very impact or threat to the fundamental rights or exploiting the vulnerability of a person. So such a system should be prohibited in EU. You cannot use this sort of system. Then there are other sort of system like for example, critical sector safety component like healthcare system, transport system, where you can use the cyber security component, right? So on that system, you need to have certain level of conformity assessment, and this conformity assessment is a part of UAI. Then finally, according to Article 52, that there are some other system like they have limited risk. Like for example, you can say about the chatbot, deepfake, emotion recognition system. On that system, you need to ensure the transparency, and clear explanation of the system. Okay, so I think the reason I put this slide is to give you, aware you that where we are moving on in terms of regulate the AI. So that means that if you are developing any AI enabled solutions, that should be classified among this one of this category. If it is in the red zone, then you cannot use them. If it is in the orange or this black zone, then you need to have certain level of compliance restrictions that you need to achieve. So what is this restriction? That maybe you need to follow the risk management, you need to follow the transparency, you need to ensure that human knows how to use the system, you need to ensure the accuracy and cyber security, as well as you need to have a comprehensive set of documentation, right? So all these things are now taking place. So that's why our research, you are not the randomly add the AI enabled component in our solutions. We also at the same time make sure that we start to make a practice of this, some of this practice of the compliance requirement. Okay. So, so that means that to achieve the minimum level of compliance, we need to make sure that how can AI make a responsible decision? So how do you know the decision make the AI is a trustworthy decision? So I think that is the key question now from us. Okay. So what is a responsible AI? So that gives you a understanding that when you use AI, that is a set of practice that focus on ethical and the legal use of the AI-based system. So that means that when you use a system, the system should be fair and unbiased. It should not be biased to some user groups, or biased. It should not be biased to any specific decision. It should preserve the social values, or it should guide you the ethical use of the AI. So that means that if you can do that, then obviously the user will increase their trust and confidence of using the AI system. All right. So that's why the one of the core component of UAI Act is to developing the responsible AI practice. Okay. So what is the responsible AI says that how could you build a trust? How could you, as I said, that how do you mitigate the bias and discrimination? So how could you ensure the compliance with the even legal requirement? And so that's we need to. This is the time now that we need to ensure all these components when you use AI component in the application domain. Okay. So it could be like fairness, as I said, with a number of techniques. It could like security to achieve that your AI model is secure enough, robust enough. It could be transparency, it could be explainability, it could be reliability. And in this talk, we are going to focus on only these two components, the transparency and as well as the explainability. In terms of that, how do you make sure that the model you develop is explainable and interpretable from the user point of view? And that we are going to implement in the cybersecurity solutions. Okay, so that is the ecosystem of the responsible AI. So if you look at any AI-enabled system, in our case, the cybersecurity solutions that has a AI components, this should have some sort of user, government agencies, and stakeholder that should regulate or that should have a certain level of expectation of using the system. And you should have an auditor. Maybe not today. When UAI Act is implemented, then you should have see the third party auditor. They can audit your systems to comply with the UAI Act. And there are social subsystem like us, like the any user group that have a certain level of expectation when you develop the AI enabled system. Otherwise, you cannot go to develop a trust or the AI solution. So when you go and AI enabled solutions, you need to look certain characteristics like fairness, reliability, explainability. Now, all these properties need to be adapted in your AI lifecycle. So by the time lifecycle, I mean that you collect data from different multimodal data. You collect data from different devices. So you need to make sure that some of the properties that I explained before is ensured there. So when you process the data, when you develop your model, when you deploy the model or execute the AI solutions, you need to make sure that certain level of characteristics should be triggered and achieve your responsible AI properties. So that's why there may be multiple devices from where you collect the data, or you use the data from existing data sets or repository. Then you process the data, you train the model, you perform the model, you deploy the model. So all of these cases in your AI lifecycle, the RAI practice should be incorporated. Otherwise, it will be very, very challenging and not today, maybe after when once AI Act is implemented to ensure that it is compliance. Okay. Then another challenge is the black box nature of the AI. As you know that when you give AI some model parameters, some data, then it will produce the output. But how do you know this output is the right output for you? Because you don't know the inner working of the model. That's why you cannot, there are lack of interpretability. You don't know how the decision is made. That is your explainability, right? So these two are very, very important, that how the model works to make the decision, and when the decision make, how do you explain the decision? And how do you make sure that this all decision making process is very, very transparent from the user point of view? Okay. So that's why unexplainability or uninterpretability is one of the key challenges that we need to take care in terms of the AI-based system. So what is really need to rectify this black box nature of the AI system? So you need to think that how the automate decision is made by the AI, or how the AI system can make an informed decision, or how could you safeguard from the vulnerability that could impact on the AI model. All these things should be taken into place when you use the AI-based system in terms of tackling the black box nature of the AI. So in our case, we discuss, as I said, that we will focus only two properties like interpretability and explainability. So what does it mean? So interpretability means that how AI model can make the decision. So how you make the decision of the AI model in terms of how you produce the output, how what is the inner working of the model. That's the one thing to answer the question of how. Okay. Now next question is why. Why the model make the decision? Like for example, why the model says that this malware is critical for your system. So that means that when you make the decision should be human understandable or human explainable decisions. Okay, so that means that you need to produce more explainable model so that user can start to trust to make your AI model using of AI model. So that's the point of the trust or the AI based system. All right. So that's the thing. So in our explainable AI context, in case of cyber security, what can happen if you want to explain the result of AI based system that use in the cyber security application? So we try to see that what are the different type of data basically used in the cyber security domain. For example, you can find there are many data that is source code based data where you are detecting the vulnerability, like CCC plus source code, Java source code. So that means that on that source code based data, it will be challenging to explain the result because source code is like a token, right? So from that token, it will be very, very difficult to understand that how the model gives this out. You have a data that is the threat intelligence data, right? For example, looking at the type of attack, the type of threat actor properties. Okay, so this type of data you can demonstrate that how the model generated, like which threats are more important for you. So this the explainability you need to take into consideration. If your data set is a malware data, then you need to look at the different types of behavior or code segments. You need to look at why this malware is behaving or probability is high in your context. Or there are some data set that belongs to the API call related data, right? So in that case, you need to look at that. What is the identify the abnormal activities or unexpected call or repeated call from that API. That could be another type of explanation the user is expecting for you. Then finally, the log-based data, like activities that may give you the potential of anomalies or suspicious activities. That in that case, that you need a other type of explainable things for your AI-based systems. Okay. So in terms of transparency, we look at that what is the inner working, like that is closely linked with the interpretability, like understanding that what type of data you use, what is the documentation you use, and how do you measure that of quality, like accuracy, completeness, consistency. How could you make sure that that follows the right level of standard or ethical guideline that need to be aware to the user to achieve the transparency of the things. Okay. So for if you want to achieve the transparency applications, but that is clearly written for Article 50 of EU AI Act, it says that transparency applications for provider and user. So who is providing you the AI solutions, or user who is using the solution for certain AI system as well as the general purpose AI system. For that system, that is a minimum level of obligations that you need to achieve. For example, you can achieve transparency from the data that you are going to use, transparency from the method you are going to use, transparency from the model outcome you can use, transparency from the explaining the result of the model that you are going to use. So all these things, I think I think very soon it will be coming in place for us for to use any AI system, but you are not discussing it. That is not going to be happen very soon. Okay. Now, from this cyber security context and the AI-enabled product and what is the regulation that you need to take into consideration, all these things we try to map in our dynamic cyber security risk management. So we call it shortly D, small cap, and CSRM. Okay, so I think most of us knows what is risk management. So I'm not going to discuss on that, but we need to focus on what are the dynamicity. Okay, we will see that what is a systematic process that consider this temporal parameter of the system, like for example the vulnerability exploitation, asset dependencies, what is the complexity of the attacks, and what is the common attack point that is always targeting by the attacker in your systems. Obviously, if you closely look, all these parameters is keep on changing. That, as I said, that vulnerability exploitation is keep on changing. So that means today's one vulnerability is more chance to exploit. Tomorrow could be another one, right? So today could be there is a one common attack point of your systems. Tomorrow it could be changed, right? So that means that you need to know these things when you do the risk assessment. Otherwise, as I told at the very beginning of my presentation, is that then you could have a wrong type of risks you are going to quantify. So hybrid model, we focus that is a combination of linear regression and deep learning to prioritize the vulnerability, and we are also adding the explainability and interpretability to define that how to use the model. Okay, so in summary, our DCSRM has four components. One is the assumptions. We make some assumptions that like asset, their dependencies. We are using some dynamic parameters, as I told before. We are using some common security knowledge, which is, I think, very widely practiced in the business, like, for example, common platform enumerations, common witness enumerations, and ISO standard. Then we are using some hybrid model to prioritize the vulnerabilities in case like extra-tree regression and deep learning and model explanation and interpretation. So all these things are combined in a single package. We call it the DCSRM. So what is the parameter? As I said, that one is the assets and their dependencies. As you know, that asset is the crucial things of a business. Without it, the business cannot be run. It could be hardware, software, or your any other ICT infrastructure. But we need to determine that what is the interdependency among the asset and how the dependency could be evolving throughout the lifetime of your business. First parameter. Second parameter is the vulnerability exploitation. As I said, that not all vulnerabilities are exploited in your system. So that means that you need to look at the exploit prediction scoring system, EPSS is called, to see that how which vulnerability could be exploited. In our case, we use our hybrid model to check that which vulnerability could be exploited in these things. Then finally, the attack complex. Like for example, how do you know that how much complex is the attack? By looking at the exploitation. Then finally, the vulnerability change. So that means that there is a number of assets, like as I said before, that cascading this, like cascading risks is due to the multiple vulnerabilities based on the dependencies of the assets. So that means that how your vulnerability is propagating from one asset to the other asset. If it is propagating, and this is not static, it will be keep on changing. And how do you measure the risk that is generated from here? So these are the parameters we are going to look for this consideration. Okay, so this is the common security knowledge that we use in our practice. Like as I said, that what are the platform software asset you are going to use, what is the common weaknesses that is imposed or main cause for your vulnerabilities, then you are looking the CB systems and risk management standard that will be used to develop our process in here. Okay, now I'm not going to discuss the detail, it will be too big to discuss, but I'm going to discuss only how we are going to incorporate the hybrid model for the vulnerability prioritization. So as I said, that hybrid means there are two different models. One is the AI model, like the deep learning model. One is the linear regression. So that's these two are combined together. Now, why we combine them? Because when you look at a vulnerability data set, there is a huge number of features, right? For example, you need to see that what are the key features for you, first things. Then how do you enhance the interpretability of using these key features? That how do you make sure that these are the right feature for you? Now, from this feature, you need to see that what is your predicted EPSS score. Then from there, you need to prioritize which vulnerabilities are more important for you. So that means in our case, we take huge list of vulnerability. From that list, we looked at which features are more important for us. Then you are using the number of EPSS score to see that which are the more prioritized in your context for the vulnerability. Then you calculate the score, and then you justify this, that yes, these are the reason why this model is generating this output, by using some explainability techniques. That is, I think, widely used, the SHAP and line method. We are use both of them in here. Okay, so that's the main contribution of discussing this. How do you prioritize this vulnerability using this hybrid model? So this is our architecture. Like, this is your data set. Like, when you talk your vulnerability exploitation, obviously you cannot generate the vulnerability data. That is generated by multiple site, multiple product specific vulnerability generated by threat actor or from the security expert. So that means that exploit DB, GitHub, Meta Exploit, and others, from there you are collecting your various repositories that you're collecting the data. When you collect the data, you need to process the data. That is the data collection. Then you use the linear regression, as I said before, in your hybrid model. And this linear regression will determine the top feature. Like, for example, dynamic parameters like attack complexity, impact. These are the top feature. Then this feature gonna feed in the neural network, like as I said, the deep learning model we use to predict the APSs. So if you can predict the APSs successfully, then you can determine which vulnerabilities are more prioritized, right? Then you can use the risk management to manage the risks that is relating to this prioritized vulnerability. Of course, when you use this AI model, then you need to explain them. That is the main contribution of our work of understanding how you explain the model. Then you need to interpret that linear regression part, that how do you interpret the result from there. So that means that when you explain the result or interpret the result, that could be understandable by the security analyst, by risk management team, the compliance officer, and the other relevant stakeholder in your system. Okay. So in these steps, there is a data collections, there is a feature generation, there is a vulnerability prioritization, there is experimental interpretation. So that's why I said that when you want to use at least some of the characteristics of the responsible AI, you need to consider the entire life cycle of the AI model. Okay. So in our process of DCSRM, we have asset profiling, like an overview of, you need to basically, I mean, how do you start the whole process? You need to know that what is the service and assets you have. So we give a screenshot for you. How does it look? So from there, we calculate the risk. So I'm not giving her details. So there are two types of risks. One is maybe one vulnerability is exploited for one asset. That is one risk for us. So that is the threat and vulnerability to a specific asset. Otherwise, we could have a cascading risk where threat and vulnerability is linked with the dependent asset, as I said, the chain of vulnerability, where multiple assets are involved. So that is our individual risk, that is our cascading risk. So both of the risks could be identified and quantified by using our approach. So this is the risk mapping. Like, from here we have a threat level, vulnerability level, impact level. So if you map it in here, so that is our threat level, vulnerability level, impact. We map it to have a semi-quantitative way to determine the level of the risks in our case, in our approach. So in the experiment, we use a data set. As I said before, that basically vulnerability data, it is more or less impossible to generate by yourself. So that means that you need to rely on existing data set from GitHub, from ExploitDB or CV data sets. Okay, so we collect one of the data set. We call it the CV. Identify the data set where there are 200,000 vulnerabilities entries there, and there are 23 attributes or features is included. For example, CV ID, unique identifier, then attack vector, attack complexity, previous required. All these things are incorporated in the data set. Okay, so that is the screenshot. Is too big. We cannot put all of them together. So that is the CV ID, CWE, the operating system, or what is the platform it is impacting, then who was the vendor, then product. So all these things is added in here in the data set that we have used. Okay. Now, as you know that in our hybrid model, the first part is to extract the feature by using extractive regression. So where we try to see that what are the key features in our system, so that we are trying to get from there, by using the linear regressions. So these are the key features, and right hand side is the associated coefficient for the key features. So that means that some features is very high influence to exploiting the vulnerability. For example, user interaction is decoded, or attack vector through the network. So these are the more highly influenced in there. Okay, and some features are less influenced from there. Okay, so from there we prioritize the vulnerability by using our deep learning model. So where we get a mean square error is very less accuracy, or R square values is like this in our case we have used. Now, out of the experiment, we see that which CVE are the highest EPSS score. So that means that our predicted EPSS score is 0.95 for this vulnerability, then 0.90 for this vulnerability. So those of them is more than I think 80% out of 100. Then we call it very high. Those of them is less than 80 to to the 60. Then we call it high. So this way we classify this vulnerability. Then this level will go to quantify the risk. Okay. So we got the specific CV, we got the specific predicted EPSS score. From there we quantify these vulnerabilities. So our result shows that I only show the top 15 vulnerabilities. So top 3 CVs in our case is this one, 20208515, which APFS score this, and the other two is, I think I already showed you in the previous table. Okay. Now if I then we try to see that is it really true that this is the top CV from that data set. Then we try to investigate more of this CV. Obviously, this CV is a specific CV that link with the DRETech router, and that is a prone to multiple command line injection attacks. So that means that it makes sense that yes, this CV is the top EPSS score. This is because this is the more chance to exploit it if user can get the root privilege from this CV. Then the second one, we see that yes, this is also makes sense that this is the top second in our case, where the attacker could send the arbitrary HTTPS request and authenticate the exchange server. So that is also high in our case, and we are using number of related CV for there. Okay, so that's the one thing we discuss the AI model, but I think our main focus is to understanding that how this result is generated. As I said, that explainability and interpretability is the key part. So we use two models like the LIME and SHAP model. So LIME focus on single prediction, like from the data set it took one instance and see that why the model is making decision, and SHAP focus on the overall the global instance, like taking the whole data set to see that why the data set is make decisions. So these two are we are using. So our assurance of explainability in terms of the LIME analysis, we see that yes, so these are the top features that I told you before, that makes sense, that has the feature and that has the value of the feature, which shows that why these features are more importance, okay, for making the decision. So that's why the value in the table is represented the actual values of the attribute and do not contribute to the feature important, that which features is more important for us in here, the assurance of explainability. Then in terms of SHAP analysis, we see that what are the key features that is more important, like availability impact is very high. And you see from this line that is the top feature from the data set that is more important. Then availability impact none, another feature is then maybe attack complexity, integrity impact, or confidentiality impact. So these are the top feature that is really influence to make the decision of EPSS score, and based on that we really prioritize the vulnerability in our case. So there's the SHAP analysis for the local importance, and this is for the global importance of the SHAP analysis in our experiment. Okay, so from there basically we try to summarize that that what is the availability impact, or how it could impact in your system, and what is the attack complexity and user interaction in the system. So all these things we are taken into considerations when you do the explainability in our case. Then how do you assure the interpretability? So as I say, that interpretability means that inner working of the model, that how do you know that model is working, and give you the understanding that how the decision is made by the model. Okay, so that's why that, so when you say that positive coefficient, in our case that user interaction required is very high, so it means that there is a direct relationship between the feature and the outcome. When is a negative coefficient, that is the inverse. That means there is no direct, like integrity impact is not a direct relationship when defining the key feature on your system. So that is basically the experiment we did. So in our case, basically we try to do a novel way of adapting the dynamic parameter. Obviously, I didn't show the all parameters, but those that is linked with the AI part, that only presented in this talk. and these dynamic parameters are using for cybersecurity risk management. That is one key contribution of the work. And another major dimension is understanding that how can you adopt the hybrid model and select the key features, and that's then finally that how do you interpret the result from the model, how do you know that are more important for producing the decisions. Okay, so these are the things we have done in work. Then finally, we try to. I think this is a work in progress. That is not the finishing work. So we try to see that specific use case scenario. Now we try to incorporate this whole DCASR, meaning specific application context, to see that how risks could be identified and justified by using this interpretability and explainable AI parameters. Okay, and how could we consider the other RAI properties? So that's basically we are now currently working to implement our work in a real context and looking at how could we incorporate the other RAI properties. Okay, so our goal basically not only dynamic risk management, but also we want to see that if you are incorporating any AI-enabled product, then we need to see that how could you assure the compliance of the UAI Act. So how do you contribute not only using AI, but also how do you contribute that you are moving toward a trustworthy AI solution so that user could be aware of your understanding. That's it from my side, and thank you for listening. Any questions?
Okay, thank you so much for the wonderful talk, Shareef. I enjoyed it a lot, and there's obviously lots of questions because it's quite a complex topic. And so maybe let's start with a little bit more general question, which is when it comes to explainability, which are the stakeholders and which are their roles? Can you say something to that? So who is providing explainability and in which role, or who wants explainability and in which role does this happen?
Okay, thank you for this interesting question. So I think if you look at the UAI Act, they say that if you are the producer of any AI model or if you're the user, for these two user group, you need to make sure that the producer or the service provider or the supplier of the AI make sure that who are the user of the AI system, they understand the system. Okay, so now when I say the who are the user, that means that let's say at a university context, the user could be the faculties, user could be the admin, user could be our management team. Okay, so they must understand. So that means that who are the users that are impacting of using this AI based system. So you need to make sure that they understand how the system works. So that is the key part. And in terms of responsibility, so that should come from the service provider who giving you the AI solutions, or the developer who giving you. So they need to make sure that all these things are there and your systems is compliance.
Mm-hmm. And when it comes, so you were also talking about the AI Act, and so this is another actor in this equation, which is regulators. So can you elaborate a bit? So what is the role of regulators? Do we need them? What is their interest? Why are they in the game?
Okay, I think main motivation is you see that now we are using AI in everywhere, right? Everybody is talk AI, AI, AI. How could you AI is in your application? How could you AI system? So I think from that point of view, all government agencies are now very, very careful because we we not only see the positive side of the AI, we also see the negative side, like deep fake image. There are many incidents that shows that negative side. I think that influence them to look at that. How could you regulate this AI? Don't talk about the positive part of the AI. You all know. So now it's come to talk about the negative part of the AI and how do you regulate them. I think that is the motivations. That's why the people, the regulatory bodies is now focused on how to regulate the AI-based system. So from that point of view, I think EU AI Act is introduced now in the across the EU. And basically what they try to say that all they classify the AI based system in four types. If you look at the triangle that I presented, like some of them are risk based approach they follow, some of them are very very high risk, some of them are high risk, some of them are medium, some of them are low risk. Now if your system fall any of this category, then you need to have a certain level of compliance. If you don't do it, then you cannot, then nobody can use your system in the EU. I think that is the main things they want to introduce. And from that point of view, if you look at the triangle, if you remember when I present the triangle, I think most of the system fall with the minimum compliance requirements. So and this minimum compliance is the explainability, interpretability, transparency, like transparency obligation acts per Article 52. So that is the minimum to start with. Obviously, this is a new thing for all of the AI stakeholders. So that means that they need to start with the minimum part, then they gradually goes, depending on the applications their AI system is fit. I hope this answered your question, right?
Yeah, very good. Would you say that explainability is enabling markets and innovation, or rather hindering it, and why?
Yeah, I think people are talking there is a trade-off, right? For example, if you want to explain the model, then your accuracy could be goes down. So I see there are some very interesting experiments. They say that if you want to increase the accuracy of your system, then obviously you cannot explain. So they are very inverse. Okay, so that means that your accuracy could be very, very high, then explainability could be down. Like some model give very high accuracy, like LLM model give very, very high accuracy when you use them for any context, but it doesn't mean that they are explainable. So I guess you need to trade off that what type of systems you are using them and how much explainability you want from them and how much robustness of security you want them. That you need to decide. Maybe this is too early to decide, but I think this is not too far that you need to start to making a trade-off among these parameters.
Very, very good. Let's stick for a second with this explainability. So can you illustrate it by some concrete examples what the explainability means for you? To be more concrete, so you have different stakeholders. You mentioned some of them already that are the recipients of the explainability information, and they might be interested in different kinds of information. So can you explain a bit what explainability means and maybe use some examples for that?
Yeah, I think one example is, let's say, for example, you are applying for your credit card, or let's say you are applying for a mortgage for your home loan. Okay, so now when you apply it, there may be a chance that your application is rejected, right? So that is the decision taken by model now. Okay, or there may be a chance that your application is accepted depending on the some of the feature, right? Now, when your application is rejected, what is the cause of the rejections? Or when your application is accepted, what is the cause of your application is accepted? So that is based, now it comes based on some feature. If your feature value is high, that means your application is accepted. If your feature value is low, your application is rejected. Now we need to know as a user that why my application is rejected, right? Then maybe the banks can say that yes, your income could be less, or your maybe you have some credit card fault income in last 3-4 years. Okay, so this correlation among the feature and the decision, that will be defined by the AI now. Okay, like out of 50,000 application, how many you are going to accept it for credit card, that nobody is doing now manually, right? So that means that some AI enabled system is there. Now when the user come and challenge you that why my credit card application is not accepted, then AI model should be robust or sufficiently trustworthy that they can explain that these are the feature, due to these feature values your application is not accepted. Okay, I think this is the explainability and the model should explain it.
Sounds good. And when we switch from that to a technical perspective, what are the requirements that go to the model, for instance? Because when we look a little bit at classical learning, deep learning, whatever learning, it's I tell the system how many nodes I want, and I give some parameters and some meta parameters, and then the system has some nodes, it has some complexity, and then in the end I feed in some data, it does some magic, and the outcome is a classifier, for instance. Am I worthy getting a credit or not? And that means when I look at such a network, it's quite hard to tell something else than saying, yeah, okay, so it went through 5 nodes in the center of the network, and the probabilities were 0.5, 0.3, 0.1, and this is why it branched like this, and now we are here. And so how do we get from this information to the explainability you talked about? Saying like, okay, so last year you didn't pay your credit, and this is why it decided like that. Because to my understanding, it's not so easy to do this correlation, because you have tons of input data, you have some magic happening, and then you have some output.
Yes. I think this is a very good question, and I would say that I think we need to understand that how the explainability work. So explainability work by looking at your data set and see that how these features are correlated. In your example from the network, let's say you are looking at the one node in the middle, one node in the end, and maybe in this node have some parameters that is important to decide that how the decision is made. Okay, so this now XCI job is to extract this node, that which node are more important to decide that how the traffic will be propagated. Okay, that is the decision made by the XCI, and they are making this XCI by looking at some algorithm or looking at some game theory to look that, let's say there are 20 features. They at first think that feature one is the top priority for me, then they play a game, then they say that no, feature one is not top, then they go to the second feature, then play the same game again. Okay, this type of theory they implied very fast, and so that at the end they extract that yes, out of this 30, this 2 3 is more important for you. So basically whatever the application domain you use, doesn't matter, this is a mortgage application, this is a malware detections, they look at the feature and they correlate them, and they see that how this feature is influenced to making you output. Okay, then they play game theory to see that which of this feature is more important to make this decision. I think this way they explain the things. This is one example of how you can use the explainability of making your decision.
Mm-hmm. And is the process that you were just describing, or is the process of adding explainability fully automatable? So is it possible to automate this, let's call it annotation process, that is making a match between the features learned and the input data that are linked to the semantics that might help me as human to understand better the decisions? Can you automate that? And if not, who would have the skills to do it, and which are the skills necessary to do it?
I think to answer your question, from my view, it cannot be fully automated. Okay, when your XCI give you some key features, you need some domain expert or subject matter expert to analyze them before disclosing it to the user. Okay, let's say in my example, the mortgage advisor should play the role of getting the feature and rationalize that why this feature is chosen on top of XCI and giving the decision to the user. In your example, the network security guy should be understanding there and looking at the feature, look at the important feature to make the decision. That means that the because our goal is to look at huge data and we cannot look as a human. That's why the AI came, right? They look at it and process it and give you very meaningful information very fast, right? Now, when you give the meaningful information, I would say this is not complete. You need some sort of domain expert to further explain the things before disclosing the accurate explainability to the user. Okay, so that means that in summary, human cannot work with the AI support, but once AI give everything to you in terms of explainability, then you as a subject matter expert must be there to understand this justification and rationalizations before delivering it to the user or aware the user doing this. So that means that it cannot be fully automated.
Mm-hmm. Okay, that's a good insight. When, as it cannot be fully automated, it does not scale, obviously. And so that means we will not have it with each and every algorithm that we will have full explainability. And so how would an expert like you say society, the regulator, and so on should decide where explainability is enforced or not enforced. Yeah.
I think our regulatory bodies is already give us a guideline. Obviously, this EU AI Act. If you look at the whole AI Act, um, is very difficult. That how do you implement it? So this is very early stage, but I think they trigger the right things to tell us that yes, this is the right time to regulate the AI based system. So from that point of view, they trigger the right things. But how they trigger or what is the details of implementation? That thing I think that needs to become now. We are still very early stage that I can say that these are the feature, that is the importance of the system. That is not enough. Okay. That's why you see some work they focus on explainability by design. Like when you start the developing AI model, you incorporate the explainability from the beginning of the system, like extracting requirement using some technique. There are some that focus on very, very advanced technique, but this is very, very limited now. Okay. So for to answer your question, for very, very wider XA adaptation, I think we need more time and we need more methods. That is still not there. Probably it will come soon. But as I said, that minimum compliance is the transparency obligation. So, but I'm expecting that this is not too far, that many new techniques will be coming very soon to discussing not only the feature, you need to go back. Like, what is the data? Why this data is necessary to making the decision? Did you collect the right data for the system? And what is missing in the data, right? And what is the extraction or management of the data? You come from there, then you go model the things and you decide the outcome and explain it. All these things will come. I think these things will come, but I think this is very early now to tell everything will be on place. This is very early to say.
Mm-hmm. How mature would you say is the AI explainability research domain? And the reason why I ask is AI, or what we call AI today, came really like a blast. So it started, or it was especially boosted already with self-driving cars with Tesla some more years ago. But then the practical interaction and use that was usable for end users, for me at least, was ChatGPT. So the large generative language models, and this came really fast. And when did this research on explainability start? And can you sketch a bit what is the focus in the research community? What are the current trends? What are the researchers looking at? Are enough researchers looking at that? And the reason why I ask the question especially also is because we also have some young audience that might be interested in, let's start my PhD. And I want to convey a bit the message that, okay, explainable AI sounds cool. I love the goals, but what actually am I doing? What are the people doing in this field? So can you shed a little bit light? I put the question especially broader so that you can focus a bit on the things that you find most interesting as someone expert in the field. So maybe you can share a bit of this experience.
I think at the end of the day, we want to achieve everybody expecting a trustworthy AI, right? So that the AI system I use is trustworthy. Everybody can trust on this system. Okay. Now, to achieve the trustworthy AI, you cannot achieve in a single day. Like you are saying that you are using OpenAI now. It is very, very powerful. Like whatever you give it, it will give you some output. You understand that the output, what is your requirement, it give you something from the OpenAI or ChatGPT, right? And you are talk about this Tesla car, that autonomous vehicle, and they have some issues on there. Okay, so I think uh, uh, LLM part is still, I don't think that they are discussing the explainability, because LLM is fully black box. They don't know what is the inner working on the model and how the model is producing this output. So this is very, very open question. So if someone focus on this area, this could be a very, very good work of understanding that how the large language model will be explained in terms of making their decisions. That could be a good work to do. And in terms of the uh, sector specific need, obviously there are many work now that focus on explainability, like explainability in autonomous vehicle, explainability in the cyber security. We talk a lot, but we know this is time now to consider beyond these two common techniques like sharp and line. This is time now to focus on what could be the other techniques that you incorporated to explain the things. Okay, because my work focus on explainability, I would say that is not that explainability everything. You need to look at the other parameters of trustworthy AI, like fairness, like you understanding the robustness. That could be another dimension. I think one could look at that. Okay, and another interesting dimension is the trade-off between them. Like you can say that my explainability would be, I want a very high explainable product. Okay, then obviously when you explain a high explainable product, then you need to go to the LLM based product, right? If you go LLM, then you cannot explain them. Okay, so that means how you achieve the trade-off between these parameters. Like if I want to expect a very high explainability, how could you achieve the accuracy or robustness at the same time? Okay, so these are, I think, and you cannot define it in a single day. You need to look at a number of contexts, number of algorithm, number of application domain where you can use. But I would say that in coming years this will be enforced very soon. So if someone uh, start this work now, they're in the front phase of the game, so very soon. And if you look at the now the funding call and the other industry call, everybody is looking now understanding that how you develop the trustworthy AI in terms of explainability, in terms of robustness, in terms of interpretability. These are basically the market needs now, the industry needs now.
Very, very insightful. So the trust. So who is developing AI models today? So these are the big tech companies, and some of them release their models as open source. Then we have some state-driven or at least state-supported activities like the Mistral in France, for instance. Which role towards explainability does the economic setting play? So which role does it play that we have these big tech companies and some smaller ones, like also the Aleph Alpha in Germany, for instance, which might be a little bit a counterpart to the Mistral in the sense that it's also a European initiative for larger language models, especially in that case. So this setting in the ecosystem, especially the focus on US-based companies, which role does that play for the explainability?
I think now, if you look at, let's say, if you go to IBM website, they already publish that how they deal with the explainability and trustworthy weather. So that means big tech player already taken their right measure to understand or implement the explainability. And as I said, that giving example of IBM, so everybody is now publishing white paper that in their internal AI model, what is their course of actions. Obviously, they are not disclosing us what techniques they use, but what is their course of actions or what is their awareness they want to give the user in terms of their product. Microsoft obviously have these things that how they deal with the explainability. So this is already coming in place towards the trustworthy AI. And in terms of the small companies, I think they will be bound to do that. But if you look at the EU Regulatory Act, okay, so like EU AI Act, when it comes in place, and they are using an AI-enabled product. Obviously, this is the time now to look at that, and they need to implement it when the EU AI Act is come in the market to fully legally enforce. Okay, that is two things. Third thing is, if you look at the EU, they have a lot of research call. That means they are very serious about this issue, and they want to. If you look at the current call, there are, I think, multiple calls. They only focus on trustworthy AI. So I think they forecast that is not that we are only giving the UAI Act, and UAI Act is coming into place. We want everyone to make it a practice in our U community. So that's why they make very call for funding proposal where the consortium can bid, and they want to see that what are the researcher and with the collaboration with industry they are doing to support their initiative in terms of the understanding the whole UAI Act and whole understanding to achieving the trustworthy. So I think is already in place, and if you the evidences I show you, they are already take it very very seriously. And obviously, as I said from the beginning, that EU is quite advanced of implementing the ethical and trustworthy AI practice. So they are really well ahead in the game comparing to the UK or US, I would say. So that's why they are implementing in practice, and all the companies they are on to operating in the EU, they have to be, take it seriously to achieve the compliance of this trustworthy AI.
In that context, let me jump back to the technical point of view. So will the introduction of explainability change the way we train our models? So will it introduce additional training phases in order to have some explainability in from the beginning to the model? Is that something that will make sense? Is that something that is already pursued?
I think to answer your question, you should consider from both ways, like explainability from the beginning of the model, as well as when your model is involved. Like, your data set can change. Like in your example, the node values can be changed, right? In my example, the application can be changed. We get more application from UK, maybe 2 years later, we get more application from the outside of UK for mortgage application. So that means that your data set is continuously evolved, right? When your data set is changed, definitely the model outcome will change. Okay, but you cannot say that I'm going to use the explainability later on. No, you need to start it from your first day of practice, that how could you explain the result. And when the model evolved, that is a new thing now, as you say, as you raise this issue, that model could be changed or data set could be changed. Now within this change, how the explainability could be adapted with this change. And I guess there is nobody now that discuss these things. We talk about explainability, but when the model start to change, how do you adapt change, and how do you put new explanation of this model, or new definition of the things, or enforce of the things, that needs to taken into consideration now.
And when you do explainability, is it so? Let's say I have a model and I have full explainability, whatever that means, and then I train some more data. Then obviously I change the model. And so is explainability, does it have an additive property in the sense that when I already have some explainability and I continue training, it's easy to still have explainability? Or is explainability rather something, I have a specific state of a model, I add explainability, and if I have another state of the model, I have to restart from the beginning?
I think you need to restart from the beginning. You cannot say that you add some new value, then your explainability can be evolved. It cannot work this way. You need to restart it with the new model, new data set. Then it will give you another value. Okay, so that means there's I'm saying you that it is the time now to look at is the model is evolved, data set is evolved. How can you top up your existing explainability? That is not done, I guess. So that is the necessary now to look at.
And that, in conclusion, that means that explainable AI, at least the way you look at it today, is not usable for online learning, right? So for online algorithms, you cannot use it.
No, I don't think so. It's all widely used now. But I think times will come that they're gonna use it for online algorithm. Yeah.
Okay, yeah, very, very interesting. Because I mean, even though I looked at the topic before, obviously, it's I'm not too deep into it. Therefore, for me, this is a very interesting insight. Let's see where to continue. Let's maybe jump back to where we've been exactly before, which was like if somebody wants to go into this field of research, we already talked about what might be questions to look at, but what is this skill set I need? Is it a lot of math? Is it a lot of semantic computing, whatever? So what would you say are the major skills? So if I would be now in my graduate studies, what subjects should I focus on if I want to specialize in explainable AI afterwards for my PhD?
Obviously, if you're very good in math, that is added advantage. But I think now the models are, the code are generated now off the shelf. You need to develop the code by yourself, and there is a huge number of functions you can call in Python and other programming platforms. I think from that point of view, I would say coding skill is very important. If someone want to jump in this domain, coding skill is very important, and data analytics skill, like from the first step of you collect the data, you extract the data, you manage the data. That is most important to understand that how data is generated and aggregated. If you don't know, then your model will be erroneous. Okay, and the decision will be erroneous. So I would say that if someone is graduated, they should look on the basics, basic understanding of data analytics, basic understandings of the AI algorithm, and basic understanding of the mathematical model. But I can make sure I can guarantee you that you don't need to be uh, very expert in mathematics. You don't need it, because now, as I told you, code is available now everywhere, so you can take the code. The thing you need to know is critical thinking, like how this modeling make decision. How do you play with this AI algorithm? That you need to know now. So I guess if someone is dedicated, even though let's say someone is not in computer science in other domain, I would say that they can still they'll be successful of achieving this.
Very good. When we talk about explainability, our focus so far was mainly on text, or like this binary or also an area decision. So with AI today, you can also generate audio, you can generate pictures, videos. Is there, and there obviously we would also love to have explainability. So how does it come? Is that a different domain, or is it still the same domain you're working on? It only has some slightly different properties, and if so, which ones?
I think this is also a very good question. So we try to the explainability for a source code vulnerability. We have some C++ source code, and we try to see which features are more important to making the decision. But we really struggle on there. That's I would like to confirm you that it's not easy to confirm the explainability from a data set that belongs to a source code. Like in our result, it says that void, percent sign, equal sign is the top feature, let's say. Now, how do you explain it? So it makes things very challenging to explain. But when we have a data set like API call, or when we have a data set like vulnerability feature, then this is very easy to do the explainability. So I think nature of the data set is important. Okay, to explainability. And when you talk about the data set X feature, I think it will be, I don't know the answer, but I see it's from the source code. We are really struggling, and to discuss that how you achieve the explainability. It's not easy to achieve the explainability by looking at the source code. Okay, so that means that type of data set is very important for you. And but then you might say me that then in that case, can you not do explainability for a source code? Yes, maybe, but the mechanism is still not available a lot. People are not discussing a lot of explainability from a source code data set, or people are not discussing a lot about explainability from a picture-based data set. So that's still, I think, work in progress stage rather than text-based. So text-based is the optimized way. If you have a text base, then this is very easy for you to achieve the discussing the explainability rather than this other sort of type of data set. Yeah.
So the how does the explainability affect complexity? Is it adding a lot of complexity, or is it rather like, okay, the complexity is in the modeling process, and the explainability adds just a linear factor, so negligible amount of complexity to the entire process?
I think I think they are more or less not friend. They are inverse with each other. Like if you try to explain them, then your complexity could be going down, right? So that means that you understand what is model is producing. So that's why I told you, remember that you have a lot of properties of responsible AI, trustworthy AI. Some of them are inversing with each other. Like for example, if you want to achieve, like let's say I give you an example to make it more, like autonomous vehicle. Obviously, in the autonomous vehicle, you want to achieve 100% accuracy, right? Like when your car is running in a road, even though there is a stop sign, car must be stopped. Now, what will happen if the stop sign is hidden due to some snow, maybe, let's say, for example, or due to some rain? Will the car still stop if you're running autonomous vehicle? So these are the open question here. So that means that you can achieve more robustness. In that case, you need to sacrifice your explainability. Okay, so these are the things is important. Now, in terms of autonomous vehicle, obviously your top priority is your robustness of the AI model, right? Your priority is not explainability. So that's why I think in a short answer, there is no right answer of your question. It should be depending on the context or application domain. Where do you use? In some contexts, explainability is more important for you to understand. And for other contexts, your robustness is more important for you. Like, as I said, that if you are using a LLM model, nobody is still explain how LLM will work and give you so fast decision. Is still black box for us, okay? That you need to trade off basically, depending on the context or application domain where you are using, I would say.
And so my naive answer would have been it's a small amount of additional complexity, but it's time-wise the largest portion, because it's something where you still have manual intervention, and therefore the model might create itself automatically, but adding the explainability is time-wise a very significant part. Would you agree to that?
Yes, I definitely agree. Yeah.
Okay, cool. To accelerate a little bit the thing and to challenge you a bit. So when I listen to what you say, it's like I use AI, which is black box, and I put some data in and it does some magic, and sometimes it works. And with explainability, it becomes more deterministic again, or at least I can understand it more. And as you just said, it might reduce complexity because you know exactly what you want to have, and therefore you can make the model less complex. Are we not developing back to heuristics where we don't need AI anymore because we want to explain everything and have a deterministic algorithm that is just doing the thing?
Yeah, I think I would say very positive way that because AI is already using in many domains. If you say we are going to restrict the AI use or we are not going to use anymore, then I think the industry will be suffering a lot. So I would say that we need to look at very optimistic way of looking that yes, we are going to use more AI, and obviously AI use will go high. And if you look some market statistics or market data of the AI, it is keep on rising. You cannot reduce the use of AI anyway. But the thing is use is high, so that means we need to regulate it. So the question is now, how do you make regulated the AI solutions and make sure that that AI solution give the right expectation of the user or the all stakeholder in the whole ecosystem, right? So I think from that point of view, I think it would be difficult now to say that we are not going to use AI anymore. Obviously, it is already widely adopted. It is continually adopting. But now the question should be, how could you regulate AI towards the trustworthy AI solutions? Okay, so that everybody is able to trust the AI, and everybody, if someone is negatively use AI, how could you take them to legal enforcement actions? Okay, that things I think now come to things taken in place.
So yeah, big fear of myself regarding the use of AI for many applications, but also for coding, is that the AI might be limiting me in my expressiveness, because it might be limiting me in what it proposes, so that I rather follow certain design patterns, even though maybe another design pattern would have been more creative towards a solution. As you're looking at explainability, I think you're also diving a little bit into that direction, because you see if the AI is reducing the feature space for the propositions and so on. Do you have some comment on that? Would you share this fear? Would you say, no, this bullshit, it's not at all like that, it's the inverse? Do you have some thoughts?
No, I think I echo with you, and I told you that when I use the source code data set to do some explainability, we failed. It's very hard to explain. So that means that if you have a source code type data and you have a number of pattern in the data, I think it is quite difficult to explain the things. Okay, so that's why there is a scope of explainability where it could be more widely adopted, what could be less adopted. No, I agree with you that that AI is not the thing that could but if you say that I want to generate a code using AI, then OpenAI could also generate your code for anything. That's fine. But when you want to say that yes, this code is right code for my context, then that is you need the human intervention. But I think now it's time that we are not going to straight away go to this from the scratch and develop the whole code. Nobody do it now. They take the off-the-shelf code or use OpenAI to generate the code and filter it by themselves. I think, yeah, that we can do, yeah.
And with that one, I fully agree with you, because when they proposed to do a moratorium of development of AI technology, so I found the idea very crazy, because it was like, of course you could do it, but it would not work. I mean, it's as if you say, here's the atomic bomb, and oh yeah, we'll not use it for the next 6 months, and good luck afterwards.
Yeah.
Okay, yeah, that's good. So what did I want to say? Give me a second. Yeah, maybe as last question. So we have this cool project, Cybersecdome, where we do cybersecurity. And could you elaborate a little bit based on the project as concrete example, how the orchestration of explainable AI could look like? You don't even have to use the project. If you have another use case, it's also fine for me. Just orchestrating it through, saying as a resume, just saying, and okay, this is the task. This is where AI comes into play. This is how it is without explainability, and this is what explainability adds. I think that would be a great sum up.
Okay. I think, as you know, that our Cybersecdome project, where we try to achieve the digital resilience, right? So now to achieve the resilience, we have a multiple component. One component is the automated pen testing that we want to do. Another component is the intuition detection. And another component is the dynamic risk management. And another component is the prophecies, right? So these are the 4 components. Now, every component is working individually, and then they'll talk with each other, right? That's what we want to do in Cybersecdome. Then when they talk with each other, at the end of the day, we want to see what is the outcome of this talking. We want to see that, yes, we can tackle the risk, we can mitigate the risk to achieve the resilience of the system. So that is our end goal to achieve, right? At the end of the day. So that means that if we have for this component, obviously some component is off the shelf that is coming from our industry partner, but other component we are developing, like for example, the automated pen testing or the intuition detection and prevention. Now, in automated pen testing, they are using AI-enabled capabilities. This intuition detection, they are using their own AI-enabled capabilities. So one thing what we can do is that this individual component may have their own explainability. Why? Because automate pen testing is taking a data set that is not similar the data set that is taking the intuition detection system. That is the real challenge in here. Okay. Second problem is automate pen testing is using one type of AI model that is not using by the intuition detection. They're using different AI model. That is happening now. So that means that explainability will not be same, definitely. Explainability is the model-driven approach. Okay, so specific model, specific explainability. Now, if we can use the same AI model, then that could be easy for a central explainability, but which we are not doing now. So that means that now only way to link them is to individual component explainability, then looking at the correlating the explainability from one component to other component, one option. Other option could be, all this component giving input to the risk management, right? Then risk management make the informed decision that yes, these are the top risks, then please control them. Then this control will go to the different component they implement it to achieve the resilience, right? So maybe when this information come to the dynamic risk management, then they do the explainability because DRM is aggregating all the information from all the components. So then it will be easy to move forward, as well as we can achieve certain level of explainability for all components, because this component is contributing to the DRM. I think that I can say to move on from that.
Very, very nice. And yeah, so a big thank you for the insights, because at least for me, explainable AI is much more graspable now. And it opened also a lot of different directions to think on and continue focusing on. So yeah, thanks a lot for having participated in today's edition. And for those who know the series, as you know, it will be available directly online. So share it with your friends. Also tell them about the website where they can subscribe for the next announcements. The next edition will be on the 30th of August. So there will not be at 2 o'clock, but at 1 o'clock Central European time. And we'll have Pascal Lafoucade from the University of Auvergne. And he will be talking about EcoCoin and Lcoin, so two crypto coins that incentivize ecology and use locality in order to stimulate some specific effects. So this will certainly be very interesting. Besides that, we also have a PhD school. I already told you about it. So it's the Future IoT PhD School, which will be from 30th of September until 4th of October at the Campus Cyber in Paris. And the topic will be IoT meets secure supply chain. You are cordially invited to participate. You can participate on-site, which is obviously the most interesting thing, but you can also participate online and either interactively via Zoom or something like that, or by following our streams on YouTube. And for both, the inscription is open, so when you click on the website here on registration, you can just register and then you get all the information. Program is online. Also share this information with your friends. There's still a few seats that are available, and this is always a lot of fun. And that's it. Thanks again for participating today. See you in 4 weeks, and enjoy the trailer of Pascal that you will see in the outro.
If you are running, taking the subway, taking public transportation, you will earn Ecomobi coin. Two cryptocurrencies that we have designed. Ecomobi coin has a goal to promote green behaviors. And the originality of this cryptocurrency is that it's not based on a proof of work, but a proof of behavior. So it's taking green mobility. In the second topic, I will talk about Lcoin, a concept of a local coin, which introduces the principle of geographical demurrage. And with this, we are able to emphasize a local economy and to have more exchange between people.
Cher CyberCNI, pôle d'excellence Région Bretagne. Au revoir et à la prochaine.